the way we do that sort of stuff is simple. What you need to do in order to keep the negatively charged region negatively charged, you have to take, this is what you have to do. All right, so I'm going to take the setup. All right, so I kind of like this, so I want to keep using this setup. So what you need to do is, I'm going to extend these a little bit more. So here's a negatively charged region. In this case, it's a metal plate. Positively charged region is also a metal plate. So in order to continuously supply the negatively charged region with electrons, what you need to do is you need to immerse or submerge both positively and negatively charged plates into an acid solution. Okay, so what does the acid do? Acid, through chemical reactions, is going to keep supplying the negatively charged region with electrons. All right, so the chemical energy is going to get converted into the electrical energy. Okay, a couple of things that I want you to notice. Number one, acid solution through chemical reactions will keep supplying electrons to the negatively charged region. All right, so which means that the strength of the electric field is going to remain constant. And notice that both terminals are separated by a certain distance, so this distance remains constant, which means that within this region, you got a constant electric field pointing in this direction, which means that the voltage and potential difference between these two regions will be constant. All right, so the amount of energy stored inside the battery is represented in terms of the voltage. The voltage is the voltage difference between these two terminals, guys. That's what it means. Now, what would happen if you bring a wire between these two terminals? All right, so if you just get a wire, attach one wire here and the other wire here, what happens? It's got free electrons, right? So what happens to the free electrons inside the wire? They will become energized. The potential energy quickly turns into kinetic energy. Do you guys make the connection that the battery is what we've been discussing forever? What the battery does, it keeps this constant electric field here because of the fact that it keeps supplying this terminal with negative charges. So the negative charges are being constantly supplied to this terminal. So the strength of the electric field is constant. The separation distance is constant. That means that it keeps a constant voltage difference within that region. So the only thing you have to do is just bring a wire here, attach one here, one there, and so all the charges will become energized. So their potential energy is going to start to turn into kinetic energy. That's it. So that's the story. And the nice thing about it is, oh my God, holy shit, guys. Unlike lightning, charge distribution is uniform here, charge distribution is uniform here. So the strength of the electric field is going to be constant, causing a constant acceleration, so the motion becomes predictable. All right, that's my Disney story. So we'll make some corrections to the story later on. All right, go take a break. Take a break, and then be back by 7:45.
Quick question before you go.
Yeah. What is it?
I've heard I don't know if this is just really dumb or if it's true, but if you put batteries in the refrigerator, do they last longer because the electrons don't want to move as much because it's colder, or is that just complete nonsense?
Okay, just hold on to that. All right, you can get the batteries to last actually forever, but just hold on to it.
Ooh, that's very important.
Okay, so
that matters.
Moving. All right, so any acid solution will do.
Because different metals have different electrical properties.
So we have two different kinds of metals here, zinc, and this would be copper, and they work as electrodes, and lemon works as an electrolyte. So let's use our little voltmeter and see if we can get some sort of charge out of this lemon.
This is a classic school science experiment. The acidic lemon juice is stripping electrons off the copper, and they're flowing to the zinc, creating an electric current.
It looks like we're getting almost a volt out of just this lemon.
Okay, so electronic symbol for everything that we discussed. So the voltage is what drives currents, so that's the conclusion. Voltage is what drives currents, so the current is going to be directly proportional to voltage. All right, so here's your battery symbol. All right, so negatively charged terminal, the positively charged terminal. Current is caused by the negative charges flowing from the negatively charged terminal towards the positively charged terminal. All right, so this is what I use. All right, so the current is, if you're a physicist, you follow the electrons. Conventional notation though. All right, so if you have a book, the book is gonna say the current flows from positive towards the negative terminal. Okay, why is that? They discovered current, obviously, long before they set up the physics of it. The guy who coined the term positive and negative, it was Ben Franklin. As far as Ben Franklin was concerned, the positive state was the excess of electrical fluid, the negative state was the deficiency of it, so the fluid would flow from high towards the low state. That's it. All right, so the convention still remains. All right, that's the convention that we use in physics, despite the fact that electrons are the ones which are flowing in the opposite direction. So just kind of remember that. All right, so I usually stick to my understanding of physics, but if you're using any of the physics books, as far as the convention is concerned, this is the way it is denoted in every single physics book, that the current flows in that direction. All right, so don't get them confused. It's the same concept. All right, so 6-volt battery is going to give you a certain amount of current. Obviously, 12-volt battery is going to give you more current, which means that the charges will be energized more. They're going to be moving faster. Faster the charges move, the larger the current is. So that's understandable. I'm going to... okay.
Out of the hospital tonight is urging dog owners to watch where they walk. This after his beloved pet was electrocuted on a sidewalk. And now city authorities are trying to get to the bottom of who's to blame. CBS 2's Sandra Torres is in Old Town for us. And Sandra, you talked with the dog owner this afternoon.
Erica, I did talk to the dog owner who was released from the hospital this morning. He suffered electrical burns to his leg and also a laceration in his hand. He is still trying to find out who needs to be held accountable. For Brian Malone, it's difficult to return to the place where his 6-year-old dog, LaDamian, died 2 days ago.
LaDamian was my first puppy ever. He was my treat to myself as a graduation from business school.
Today, there's just a small spot covered in cement. But as this picture shows, on Monday, there was an orange cone with electrical copper wiring attached to the fence. LaDamian got too close to it.
And next thing I know, LaDamian was shrieking and yelping and spasming like I've never heard. And looked like he lost control of his back legs. He eventually went down.
The mutt died instantly, and Malone ended up getting hurt while trying to help him.
And in the process of me just trying to administer CPR, suffering burns up my leg from the voltage.
Now he's trying to find answers as to why the cone was there in the first place.
To have a residential fence be revealed to be electrically live 2 weeks ago, and then to not quarantine that off, and just to have some ground wire installed into the ground on the exterior of the fence, meaning on the sidewalk, that just doesn't make any sense.
And the city tells us it appears a private contractor was working on that fence, which is owned by the Marshfield Garden Apartments. And in a statement, they said that they are aware of this incident and that they are cooperating with the investigation. In the meantime, the dog owner is definitely considering looking into legal action. Live in Old Town, Sandra Torres, CBS 2 News.
All right, so here's a question for you. Why did the dog die and nothing happened to the owner?
Because the dog baby bone arrow wasn't really as strong as our body, or maybe like a brain that's strong as our body. I'm not sure.
All right, I'm gonna give you 5 points for venturing a guess. Who's got a different explanation for it? Why is it that the dog died, not the owner?
Because his heart is closer to the ground, so the current passed through his heart.
All right, so that's not a bad explanation. I'm gonna give you 5 points for that one. Who's got a different explanation? All right, are we done? Okay, guys, it's related to step potential, right? All right, so what's the step potential? All right, so imagine that you got a region of two opposite charges. So there's going to be an electric from left to right. Oh my God, this is awesome. And then you got the separating distance, which is R. So this is the amount of voltage difference, right? The larger the voltage difference is, the bigger the current is going to be. All right, in terms of the step potential, so this is the region which is electrified, and then you walk in there, and then you put 1 foot here, and the second foot right there. What's the separation distance between these two? It's relatively small, right? So if you're looking at the separation distance between these 2 points of contact, smaller the separation distance is, smaller the voltage difference is, the less current is going to go through your body. You got it? You understand the difference? If a dog is big, you got the front legs and you got the back legs, and then obviously larger separation distance, larger voltage difference means a lot more current is going to be, a lot more current is going to be going through the body. That's what happened. Owner, in this case, his feet are close to each other. All right, so the potential difference is not that big. More than likely, you didn't even notice that the ground was electrified. If this guy had a smaller dog, the dog would have been fine. All right, so it's a step potential. The step potential is referring to the separation distance between the contact. All right, the ground was electrified, which means that there was an electric field within that region. So at that point, it depends on your contact. If the legs are further apart, potential difference is going to be large. More current is going to be going through your body. All right, that's it. That's the reason why. So the larger the potential difference is, more the current is going to be. All right, so this is your battery symbol. All right, so the first conclusion is current depends on the voltage difference. All right, so the current is going to be proportional to the voltage difference. Okay, once you run a current through the circuit, once you start running current through the structure, the metal or whatnot, these charges will not be moving unimpeded. They will experience some resistance. All right, so the resistance is whatever resists the motion of these charges. which could be represented using the letter R. The R represents the overall resistance the charge will experience against their motion, impedance or resistance that they will experience. All right, so how fast the charges move is going to be inversely proportional to the resistance that they will feel against their motion. So the letter R represents the resistance. The proper unit is ohms, so either use that omega, or we use the letter, or use ohms in general. They mean the same thing. All right, so it's going to represent the overall resistance that the charges will experience, which means that the resistance is going to slow down the flow. That's what it means. All right, so electronic symbol for resistance is going to be represented. Overall resistance is represented by the symbol. There are devices that are designed to offer resistance, so these are known as resistors. So this is the resistance of a resistor. And then, so now we got two conclusions. Conclusion number one is voltage is what drives current, and what slows down the current is resistance. So we got two conclusions, two observations. All right, so obviously you got one proportionality here. You got a second proportionality here. All right, so the guy named Ohm is the guy who puts these two observations together. He says the current is directly proportional to voltage, inversely related to the resistance. And then he comes up with the equation. The voltage is what drives current, and what diminishes current is resistance. This is known as the Ohm's law. All right, so this becomes the Ohm's law. All right, so electronic symbol for Ohm's law is going to be this. So you got your battery. The current is going to flow in this direction, and then experience some resistance, which means that it's going to slow down, and that's it. All right, so voltage is what drives the current, and resistance is what slows it down. The larger the voltage is, the larger the current is. The larger the resistance is, the smaller the current is, slower the charge will move.